Hello everyone and happy Steel Day. Welcome to AISC's webinar, Designing in Structural Steel 2017, presented by Larry Kruth. Today is September 15th, 2017. My name is Christina Harbour and I'm with AISC's Continuing Education Group. I'll be moderating today's presentation. I want to introduce today's speaker. Larry Kruth is the Vice President of Engineering and Research at AISC in Chicago. Larry spent most of his career at Douglas Steel Fabricating in Lansing, Michigan, where he was most recently Vice President. He has notable expertise in fabrication and erection, quality systems, safety, and connection design. He's a licensed engineer in Pennsylvania and Michigan. Welcome, Larry, and I'll let you take it from here.
Thank you, Christina. Well, today's presentation is going to cover the AISC's 15th edition Steel Construction Manual, the specification for structural steel buildings, and a code of standard practice for steel buildings and bridges. That's quite a bit of information to try to cover in an hour. In fact, most of the time, each one of these subjects would take at least an hour to cover. And in fact, AISC has some seminars that this whole subject is covered in about a 4-hour seminar. Really, to try to cover this in an hour would be like trying to eat this 10-course meal all in 1 hour. You know, it's virtually impossible to be able to eat a 10-course meal in 1 hour. So today, what you're really going to get is something more like this. You're going to get some appetizers, a little tidbit of each one of these to give you an idea of what each one of these are about, so you can dig into it on yourself or attend one of the seminars that we will be offering in the future in your area. When most people think about AISC, they think about the Steel Construction Manual. I want all of you to realize the Steel Construction Manual, although it's a handy document and it's a handy book to have, has a lot of good information into it, I want you to realize that in the 2018 International Building Code, what is referenced is the specification for structural steel buildings, which in turn in Chapter A references the Code of Standard Practice for steel buildings and bridges. What that means is this is the only part that is an integral part of the building code. The manual is not. The specification is part of the building code, which in turn references the Code of Standard Practice. So I want you to realize it's not the manual that's referenced, but the specification and the Code of Standard Practice. In light of that, the first subject we're going to be covering is the AISC specification for structural steel buildings, or AISC 36016. When you look at the table of contents for the specification for structural steel buildings, you're not going to see many changes in the table of contents. Some of the subject matter in the specification itself has changed, but the table of contents really has not changed that much. There have been some changes in the titles of some of the chapters, though, because when you go on to Chapter K, you're going to notice that instead of it being titled Design of HSS and Box Member Connections, it's now titled Additional Requirements for HSS and Box Section Connections. The reason is a lot of information that was in Chapter K previously is now covered in Chapter J, because Chapter J deals with connections in a more generic fashion that addresses HSS and box members as well as regular connection members as well. Chapter K is just additional information beyond what is covered in Chapter J. Going on, you'll see that Appendix 1 has been retitled from Design by Inelastic Analysis to Advanced Analysis, because there are other methods of analyzing rather than just inelastic. Appendix 3 has the words designed for drop from fatigue, and it's just called fatigue. And the reason for that, there are more issues in fatigue than just design. It also addresses issues for fabrication and fatigue, so you have to keep that in mind at the same time. Appendix 6 has been retitled from Stability Bracing for Columns and Beams to Member Stability Bracing, again because Appendix 6 now addresses not just columns and beams, but other members as well. Getting on to the changes that you'll start to see in the 2016 specification, there are new specifications referenced. The references are the 2016 AISC E7, the 2015 AWSD 1.1, the 2014 RCSC specification, and the 2014 ACI 318. In addition, you're going to see some new standards for material, and some of the new standards deal with HSS members. There's ASTM 1065 and ASTM 1085. These are new ASTM standards for HSS material. Both of these are 50 KSI material. In addition to that, ASTM 1085 also has some Sharpie requirements that are required with it that will make it more suitable for seismic applications. Both of these as well, you're able to use the full thickness of the HSS material. Keep in mind, A500 only allowed you to use 93% of the thickness that was specified. For ASTM 1065 and ASTM 1085, the full thickness of the wall can be used in your design, as well as a full 50 KSI strength of the material. Going on, there are new bolt standards. There's a new umbrella bolt standard, ASTM F3125. What most of you are used to are A325 bolts, A490 bolts, F1852 bolts, and F2280. There were issues with the manufacturing processes that were specified in all of those old ASTM standards, and they've all been unified under one standard, F3125, and now those bolts are now going to be called F3125 grade A325, grade A490, grade F1852, and grade F2280. Also added are ASTM F3043 and F3111. These are 200 KSI bolts. The F3043 are TC bolts, and the F3111 are heavy hex bolts. These are 200 KSI bolts. They're very strong bolts. They do have some limitations in use. Make sure you look at those standards before you use them. AWS A5.36 has also been added. This is a new standard that it will be replacing AWS F2.0 and A5.29. As these get replaced, A5.36 will be used. Going on to changes in Chapter D, there are revisions to shear lag in Table D 3.1. What we discovered when looking at this, what was addressed in 2010 is with the picture you see on your left. That picture you see on your left indicates basically both the weld being the same size on a tension member you see there. Well, it was determined that there are cases when you might have different weld lengths on both sides of that tension member, and that was never addressed. This is now addressed in Case 4 in Table 3.1 for the shear lag factor. It's actually addressed pretty simply. If you actually look at the formula for shear lag as revised Case 4, it's pretty simple. All you need to do is basically take the average of the one weld length with the other weld length, and if it's greater than or equal to, has to be greater than or equal to 4 times the weld size. This was based on research that was done by Pat Fortney and Bill Thornton, and it appeared in the AISC Journal in 2012. Chapter E has new criteria for the design of compression members. One of the major changes you're going to see in here is KL is no longer used for effective length, but L sub C is. Slender element member is a revised procedure for no more Q factor. I know most people have been very concerned about this, about KL disappearing at this time, but I want to give you a little bit of history of K. The K factor was first introduced in 1963. Prior to that, Euler buckling was the only thing that was used for compression members. It is set equal to 1 when using the direct analysis method in Chapter C, and it's been that way since 2005. For 2016 KL, the effective length has been replaced with L sub C. So that makes it pretty simple when you're doing your analysis. You're just using L sub C. Traditional definition of K is not helpful in this case. And that's been implemented throughout the 2016 specification. Well, I know a lot of people may be concerned about this. Well, I want to show you that in the commentary for Appendix A, there still is the old table for K factors that you can look up and still can use if you would like to use them. They haven't disappeared. They're still there for you to use. But keep in remember, L sub C is no more than KL in a different format. Chapter J has quite a bit of changes for design of connections. The first major change is bolts and combinations with welds. That's in Section J 1.8. Previously, this section was thought to be used mainly when there was retrofit of an existing building. Sometimes that retrofit came during construction as loading change. What was in there previously became not really useful, and it was determined that it really was not being used very much in practice as well. It's been changed extensively. I think you need to read it to understand what is involved with it. Keep in mind, I'm only giving you a tidbit of what's in the chapter. There are new ASTM bolt standards in Section J3, and there's a new bolt Group C in Section J3 as well. We'll go into those in a little more detail. We talked previously about the new high-strength bolt specs, ASTM F3125, and the different grades. So the standard is F3125 grade A325 for Group A bolts, or grade F1858. For Group B bolts, it's ASTM F3125 grade A490 or grade F2280. For Group C bolts, they include the ASTM F3043s and the F3111s, the 200 KSI bolts. With the changes that have occurred in the new standard, the F3125, there have been some additional changes for bolt pretensions and a change in minimum bolt hole sizes. We'll go into those in more detail. One of the changes that occurred with F3125 is that for all Group A bolts that are larger, grade equal to or larger than 1 1/8 in diameter, the bolt pretension has increased. That increased because what was discovered is that the old A325 and the F1852 standard that was originally being used for bolts said that bolts that were 1 1/8 and larger were made from 105 KSI material. Discovered that the manufacturers were using 120 KSI material for all those bolts, no matter what the diameter was. Because they were using the higher strength material, there's a higher pretension required to develop the strength of those bolts. But you get the added advantage of the higher strength material, and the bolts are stronger for 1 1/8 and larger for all Group A bolts. If you go to Table J 3.3, you're going to see that the nominal hole sizes for standard, short slots, and long slot widths when the bolts are 1 inch or larger in diameter increase to 1/8 inch oversize. This is a change from what has been traditionally used of a 1/16 inch oversize. Why was that change made? Well, what was discovered is on those larger bolts, the bolts did not fit in the holes. These were due to the manufacturing standards for those bolts. So upon investigation, we discovered that there was research that was done as long ago as the 1950s saying that an 1/8 inch oversized hole does not adversely affect the strength of the bolt in the least bit. Now, granted, we are conservative when we make these changes, and it took us since the 1950s, but we're making the change now that for 1 inch and larger bolts, you can be at 1/8 inch oversize. Now keep in mind, it's permitted to be an 1/8 inch oversize hole. You still can use a 1/16 inch oversize hole if you would like. There is no effect on strength either way. Going on in Chapter J, there are new minimum bolt hole clear spacings in Section J 3.3, a revised presentation for bearing and tear out equations in Section J 3.10, also incorporated HSS connections in Section J10. As I told you, a lot of that stuff was moved from Chapter K into Chapter J. And all the washer requirements were referring to RCSC now. Previously, there were washer requirements in the AISC specification and washer requirements in RCSC. And rather than trying to keep those coordinated, it's easier to just refer to RCSC and use the washer requirements that are in RCSC. Moving on to the Code of Standard Practice for Steel Buildings and Bridges, AISC 30316, we're going to cover a lot of changes that have occurred in that. One of the major changes that have occurred in the Code of Standard Practice, for the first time ever, AISC 30316 is now an ANSI standard. It had never been an ANSI standard before. So what's involved with being an ANSI standard? Well, it's required that the committee that writes the Code of Standard Practice be a balanced committee. So it's made up of 7 fabricators, 7 engineers, and 9 others, including a general contractor, a code official, a quality consultant, an erector, detailer, architect, an attorney, and that the entire Code of Standard Practice went through a rigorous public review process before it was published. That's how it became an ANSI standard for 2016. There were some changes that occurred in the table of contents for the Code of Standard Practice. They began in Chapter 3. Previously, it said design drawings and specifications. We're going to go into why this is changing because it has to do with models. It now says design documents. Chapter 4 was previously titled shop and erection drawings. It's now titled approval documents. Also, you will notice that Appendix A, the digital building product models, is totally deleted. That's because all the model language has now been incorporated integrally right into the Code of Standard Practice. We're going to go into that in a little more detail to show you how that is being covered. There are actually 3 major revisions in 2016. As I said, models, stiffening, and architecturally exposed structural steel, AESS. We'll handle each one of these subjects separately. We'll start with the models. Well, what's happened is when most people are looking at designing a building or anything along those lines, even taking a structure, they would model it in their design software, transfer it into a detailing model, and the goal is by doing this integrally altogether, it reduces error, and what you're going to get is something seamless like that, where a model automatically turns into a building such as that. Well, models are being used more commonly and actually become standard practice more than it was in the 2010 when the last Code of Standard Practice was written. Because of that, model language has been incorporated throughout the new Code of Standard Practice. We'll go into some of the changes that have occurred in that area. In 2010, the term was design drawings. In 2016, the new term is design documents. The definition for design documents is the design drawings, or where the parties have agreed in the contract documents to provide digital models, the design model. A combination of drawings and digital models may also be provided. There's also a definition of a design model, a dimensionally accurate 3D digital model of the structure that conveys the structural steel requirements given in Section 3.1 for the building. So you can see, even though we eliminated the term design drawings, it does appear in the definition of design documents. That means you can still use drawings, or you can use a model, or you can use a combination depending on what you want to do contractually. It's all up to you. Fabrication documents is a new term that replaces shop drawings. Shop drawings does not appear in the glossary. So fabrication documents is defined as the shop drawings, or where parties have agreed in the contract documents to provide digital models, the fabrication model. A combination of drawings and digital models may also be provided. Now, the fabrication model is defined as a dimensionally accurate 3D digital model produced to convey the information necessary to fabricate the structural steel. This may be the same digital model as the erection model, but is not required to be. Again, very similar terminology. Erection drawings has been replaced with erection documents. And you look at these definitions, they match what we just talked about previously. The erection documents is either the erection drawings or it can be an erection model or a combination of either one. And the erection model, again, can be the same as the fabrication model, but doesn't need to be the same. We're giving flexibility contractually of whatever you would like to do. This is a new term, approval documents. It sort of replaces shop and erection drawings. An approval document says the structural steel shop drawings, erection drawings, and embedment drawings, or where the parties have agreed and the contract documents provide digital models, the fabrication and erection models. A combination of drawings and digital models may also be provided. This term was developed because model approval is being done more commonly. People are exchanging models. A design model is being sent to a detailer produces a model. That model is being sent back to the engineer of record for approval and sent back for corrections and then being used in the shop. So instead of using just the term shop drawings and erection drawings, it is an approval document which can be either drawings or can be a model. This covers both cases. It gives you more flexibility contractually of whatever you would like to do. The next major subject that is changed in the Code of Standard Practice is stiffening. In 2010, Section 3.1.1 states column stiffeners, bearing stiffeners, and doublers, etc. must be designed and clearly shown on the drawings. Section 3.1.2 states 3 options for connection design indicated by the owner's designated representative for design. That means there are 3 options that can be done instead of 3.1.1. Because of that, what was happening is you'd get drawings that look similar like this. You would get a connection shown like this, a MoMA connection. It probably had loads shown on it, needed to be designed, but there was a note that continuity and doubler plates as required. Well, in the process of bidding, what was happening is some bidders would include continuity and doubler plates, and some would not. It made for unequitable bids. So in 2016, there is a change, and the change occurs in Section 3.1.1. There's Option 1, which says the engineer of record provides complete connection design. Option 2, the steel detailer selects and completes the connection design. And Option 3, a licensed engineer working for the fabricator provides complete connection design. Those are the 3 options that are in 2016. Going on, it explains in Section 3.1.2 that if Option 1 or 2, the owner's designated representative for design designs stiffening and shows on the structural design bid documents what's required. If Option 3A is included, the owner's designated representative for design designs stiffening and shows what is required on the structural design bid documents. There's a third option. If Option 3B is chosen, the owner's designated representative for design provides bidding quantity for items for stiffening, an estimate. If no estimate is provided, stiffening will not be included in the bid. So that means that you have an option. As being the engineer of record, you can show what is required for column stiffening if it is required. And if you do not show it, you have to provide a bidding quantity. That means if you say, for example, that 70% of the members are going to require stiffeners and doubler plates, then when the estimate comes in, it will include that 70% of the connections will include it. If the actual quantity ends up being less than that, let's say 50%, the owner will get a credit for what was included in the bid. If the actual quantity is greater than that, say 80%, the owner then will be paying for what is required. It's a more equitable way of pricing it by using option 3B. The next major change in the Code of Standard Practice deals with architecturally exposed structural steel. When you're looking at architecturally exposed structural steel, we look at things that look like this. This actually is the Ave Maria Oratory at Ave Maria University in Florida. You can see the beauty of architecturally exposed structural steel. But what has happened over the years is because different people have different visions of architecturally exposed structural steel. A lot of people would look at this and think, this is what I always think of architecturally exposed structural steel. Well, because of that, Section 10, which deals with architecturally exposed structural steel, has been completely changed. If you look at what we had in the past, you may have seen this supplement to Modern Steel Construction, architecturally exposed structural steel, that appeared in May of 2003, or you may have seen this board that was produced by the Rocky Mountain Steel Construction Association that shows a lot of samples of what architecturally exposed structural steel looks like. This is what people have been using for quite a few years. Well, there was a lot of confusion on what people really wanted in architecturally exposed structural steel. Well, a few years ago, the Canadian Institute for Steel Construction developed this document, Guide for Specifying Architecturally Exposed Structural Steel. Well, the Code of Standard Practice Committee reviewed this document and found a lot of good information in this document and tried to incorporate this information in the 2016 Code of Standard Practice. So as I said, Section 10 is completely changed for architecturally exposed structural steel. It now has 5 separate degrees of architecturally exposed structural steel. It has AISC 1, which are basic elements, just basic architecturally exposed structural steel. AISC 2 are feature elements that you would view from greater than 20 feet away. AISC 3 are feature elements that are be viewed at less than or equal to 20 feet away. AISC 4 are showcase elements with special surface and edge treatments. These might be elements you might really want to run your hand over. It's a real fine finish, maybe closer to what you might see on an automobile or something like that. AISC C is custom. Now, custom is not defined. And the reason it's not defined is it might be something beyond what you see here, a little less, or a mixture of them. It's up to you how you would want to structure it. Well, another way to look at this may be like this. Keep in mind that as you step up on each grade from 1 through 4 into C, the costs are going to increase dramatically. So keep that in mind when you're looking at this. Don't specify more than what you really need. Don't have the costs increase more for the owner than what is really required. Some other revisions that we're not going to have time to go through, but we'll go through these briefly, are lack of tolerances, identifying protected zones, handling the cost of revisions, and anchor rod placement tolerances. So we'll go through these a little briefly. Section 1.10 says there's no zero tolerance. What happened was previously, if you look at what states here, tolerances for materials, fabrication, and erection shall be as stipulated in sections 5, 6, 7, and 10. Tolerances absent from this code or the contract documents shall not be considered zero by default. There were cases where people were looking at section 5, 6, 7, and 10 and looking for material tolerances, fabrication tolerances, erection tolerances, and AISC tolerances and said, well, if they're not listed there, they must be zero. Well, that was never the case. These are the only tolerances that are specified. If you want any tolerances beyond what's specified in sections 5, 6, 7, and 10, you need to specify those in the contract documents. Keep in mind there'll probably be added cost for that higher tolerance. Marking of protected zones in high seismic applications. There is a protected zone in every high seismic application, and there's a requirement to be marking those. It's always usually are marked during construction, but sometimes those marks got covered up by fireproofing. And as time went on during the life of the building, nobody knew where those protected zones were, and items were attached in those areas. So there's now a requirement in Section 1.11 that you have to permanently mark those areas. They can be permanently marked with paint. They can be permanently marked with a sign. There's a number of different ways these can be marked. You can be creative in how you mark these, but these areas have to be permanently marked in some manner, maybe on top of the fireproofing, maybe with a sign. It's up to you to determine it, but it's now required to be permanently marked for the life of the building. And Section 7.5.1 deals with tolerances for anchor rod placements. They've been revised to be more in compliance with what's in the AISC manual and in what's in ACI 117. So we're not going to go into that any more in depth. You can read that for more information. At this point, we're going to begin coverage of what the changes that have occurred in the 15th edition AISC Steel Construction Manual. When you look at the table of contents, the titles of each one of the parts of the Steel Construction Manual have not changed. You can see 1 through 9, the titles are exactly the same as they have been in the 14th edition. Continuing on, when you look at sections 10 through 15, you're going to see those are actually titled exactly the same. There have been changes in these sections, but the titles in the table of contents have not changed. Part 16 references the new standards. We just talked about the 2016 AISC specification for structural steel buildings, and we talked about the 2016 AISC Code of Standard Practice for Steel Buildings and Bridges. Also included in Part 16 is the 2014 RCSC specification for structural joints using high-strength bolts. Part 17 contains all of that miscellaneous data and mathematical information that all of us use and refer to from time to time for different formulas to help us with our design work. So Part 1, what items have changed in Part 1? Well, there's new shapes. There's new W shapes. There's new HP shapes. There's new angle shapes, new HSS shapes, and new pipe shapes. We'll go through those in detail at this point. If you look, there have been some very large wide flange shapes added. You can see we have W14s at 873. We also have a W36 by 925. These are very large, very heavy shapes that you may be able to use in your design. I would caution you, before you use any of these shapes, make sure you check availability on AISC's website and with your local fabricator as well to make sure these are available or readily available in a timely manner for you. There are new HP shapes, HP 12 by 89, and some very large angles, up to 12 by 12 by inch and 3/8 angles that were added. So you can see there's be some advantage for some of these very large, heavy shapes. Again, check availability before you just randomly start to use them in your design. New HSS shapes. We're up to 22 by 22 by 7/8 and 3/4 for square HSS shapes. And also for rectangulars, we have 24 by 12 by 3/4, 5/8, and 1/2 inch. These are available from manufacturers, but again, check AIC's website for availability as well as your local fabricators, because just because there are manufactured doesn't mean they're available in a timely manner. Same with the new pipes, up to 26-inch diameter standard and extra strong pipes, and 12-inch and 10-inch double extra strong pipes. Check availability because timeliness is important on every project. Also, in consultation with the mills, they had told us that the fillet radii have changed, which in rolling tolerance has changed. Therefore, it changed the K detailing, the K1, and the T dimensions for these wide flange shapes as well. Refer to these in the table 1-1. These have changed. They're all in Part 1 on dimensions and properties. These have changed for quite a few shapes. Make sure you refer to those in your designs. With those larger double angles that are being used, if you use double angles for the 12-inch or the 10-inch angles, you may need a larger separation if you're using those as double angle braces. For example, if you start to look at some of these double angle braces, you can see we have separations that are 3/4 inch, 1.5 inches. You may have larger gusset plates you need to use with these larger angles for double angle braces. So you need that larger separation between them. The properties are in Table 1-15 for you to follow and find that information. There are also some general design considerations in Part 2. Table 2-4 is the Apple ASTM specification for various structural shapes. 2-5 are the ASTM specifications for plates and bars. And Table 2-7 is a summary of surface preparations. We'll go through some of these at this point. If you look at Table 2-4, you're going to see a change under A500. You're going to see that grade C is now the preferred grade for A500 material. So what does that mean? That means if you're using a rectangular or square A500 HSS, you now can use a yield stress of 50 KSI instead of 46 KSI. Take advantage of that added strength in your designs. If you're using a round, you can now use 46 KSI instead of 42 KSI. Make sure you take advantage of this as a preferred grade of that material. Use it in your design. When you're looking at plates and bars, Table 2-5 shows that for a lot of the thinner plates, we're talking about plates and bars up to 4 inches thick, again, 50 KSI is the preferred material to be used at this point. You still, for some of the thicker ones, for over 4 inches up to 8 inches, 36 KSI is what you're going to be used as the preferred material. Over 8 inches, 32 KSI. But you can see the preferred material for most of the common plates you're going to be using in your design now has a yield strength of 50 KSI. Part 4 is a design of compression members. Now we've talked previously in the specification about the elimination of the K factor in tables, and now we're using L sub C. You can refer back to that information to see what's involved in there and look at the manual. There's a good discussion in the manual as well as in the specification on that. It also clarifies that C sub W is equal to 0 for WT column tables. Chapter E has revisions in the tables for slender members. Double angles members use the more general FCRY equation. Tables for composite columns 4-13 through 4-20 have been removed. Now they will be available on some of the resource material we're going to go through a little later that is not in the manual any longer. And the W-shaped column tables, we've added 65 and 70 KSI material for some of the column shapes. We'll go into look at those at this point. You can see that for some of the larger column shapes, you see those large W14s we were talking about previously, they are available now in 65 KSI material and 70 KSI material. Again, make sure before using these you confirm availability on AISC's website and with your local fabricator to determine how available they are for your project in a timely manner. But you can take advantage of this added strength. I think this is one of the most exciting additions to the manual. It's the super table. I think this is going to be a great aid to design, the whole design community. I really like this. I think it's a great tool. I think we'll go through an example to show you how this will be used. The example we're going to be using is we're going to look at a W14 by 99. Again, with a K equals 1, so L sub C is going to be the actual length, which is 14 feet. So we're going to check the shape for combined loading using LRFD with the required strength as follows. The required compressive strength is 400 kips. The strong axis bending requirement is 250 kip feet. The weak axis bending requirement is 80 kip feet. Going into table 6-2, the super table, you look across the top, you find a W14 by 99. You go down the table to the length of 14 feet, and you read across to the LRFD strength, and you're going to see for compression, it's good for 1,130 kips. In strong axis bending, reading across to the right, you're going to see it's good for 642 kip feet at 14 feet. Comparing those, this is the original design we had. We required 400 kips, and we required 250 kip feet. We are exceeding both of those numbers with what the values were in the table. Continuing on in the same table, you look at the weak axis bending capacity, and you're going to see that's good for 311 kip feet. Going back to our design requirements, we only required 80 kip feet, so that is acceptable in that case. Taking that information and going into the solution, we take the actual compression load on the column, 400 kips, divide by the allowable, and that comes out to 0.354. Well, that's greater than 0.2, so that refers you to use specification equation H1-1A, which you see following below. Plugging into that equation, as you can see with all the variables we look at, which was the 400 divided by the 1130 plus 8/9 of the quantity of the 250 kip feet divided by the capacity of 642 kip feet plus the 80 kip feet divided by the capacity of 311 kip feet, work it out to an interaction equation, and you could see the result is 0.928, which is less than 1. That works. It's that simple to do that complicated design by just using the super table and plugging into this equation. It's very simple. It should save a lot of time and design of members. Table 10-1 has some changes. If you look at Table 10-1 on the left, you'll see it was in the 14th edition, and there was a table at the bottom that talks about beam web available strength for inch thickness in kip inches. That bottom table caused a lot of confusion for a lot of people. It was very difficult for people to figure out how to apply it because it had a lot of limitations built into it. In fact, many people didn't understand how to apply it, and they had a tendency to apply it incorrectly or ignore it. Well, it's being removed in the 15th edition. It doesn't mean those checks don't still have to be made. You will use the specification to make those checks for the beam available strength, but you would use the formulas in the specification instead of using a table to check that. We're trying to work on another alternative to be able to replace that table in the future, but rather than continue to cause confusion for the design community, that table has been eliminated from Table 10-1. That portion of the table has been eliminated. So you're just going to see bolt and angle available strength listed in Table 10-1 and this 15th edition. One other change in Part 10 deals with extended single plate shear connections. In the 14th edition, there was a formula that was shown that was based upon an engineering journal article that was published in 2011 by Pat Fortney and Bill Thornton about the use of stabilizer plates. Well, Pat Fortney and Bill Thornton published another article in 2016 saying that really the stabilizer plates are not necessary. So the whole method of using stabilizer plates for extended single plate shear connections is no longer included in the 15th edition manual. But what is included as well is a method to design double row extended single plate shear connections as well. So again, you don't have to use a stabilizer plates any longer, and there's a new method for double row single plate shear connections in the 15th edition manual. There's also in Table 10-14C are some added weld details for skewed single plate shear connections. Now, all of you know run into single plate shear connections, and they're skewed, and there have been methods previously published in the manual, the 14th edition manual, for welding single plate shear connections. Well, now there are methods for both 36 and 50 KSI plates, as well as up to 5/8 inch thick single plate skewed shear connections. So this table was added, Table 10-14C, to give you more information about how to design skewed single plate shear connections. Also, a change that occurred in Part 14 for the anchor rod hole sizes. In the 14th edition, we had sizes that were listed there, and you could see from this in Table 14-2, in the 15th edition, all of these sizes got larger. Now, these sizes got larger to accommodate what is required in the field for installation, and also it refers back to the hole sizes provided in compliance with ACI 117. One other change, ASTM F844 washers are permitted instead of plate washers when the hole clearances are limited to 5/16 for rod diameters up to 1 inch, 1/2 inch for rod diameters over 1 inch, and up to 2, and 1 inch for rod diameters over 2 inches. Now, what you have to realize is that it was always expensive to make plate washers. If you can use a standard off-the-shelf washer, an F844 washer, it is also always less expensive and will reduce costs on your projects. So there's an advantage to allowing people to use a standard washer rather than requiring everybody to use a plate washer. So I'm going to summarize the changes that are in the manual. Now, I did not go over all of these changes, but this is sort of a quick summary. Part 1 has new shape sizes and detailing dimensions. Part 2 has ASTM grade C now as preferred grade for HSS members. There's new footnotes in Part 3. The W-shaped column tables for 65 and 70 KSI columns are in Part 4. Part 6 is the new super table, Table 6-2. Part 7 and Table 7-14 includes TC bolt dimensions. Part 8 has new plastic method for eccentrically loaded bolt groups. Part 9 has increased permitted tributary length for prying action. Part 10 removes the stabilizer plate provisions for extended single plate connections. Part 13 has additional considerations for HSS to HSS truss connections. Part 14 has an updated Table 14-2 for approved anchor rod installation. Also, design examples, which are on the resource pages at AISC. These are not available for the 15th edition at this time, but will be available before the end of the year. Part 1 has design examples based on the AISC specification for things such as tension members and compression members. Part 2 has examples based upon the steel construction manual, which are simple shear connections, fully restrained MoMA connections, and Part 3 has system design examples. That has a design method for selected 4-story building members. Part 4 has additional resources that you might find available. Keep in mind, we talked about some items that were removed from the 15th edition manual that appeared in the 14th edition manual, such as combined flexural and axial force W shapes. That was Table 6-1. That'll be available on the resource page. Filled HSS column tables for A500 grade C. That were tables that were previously Table 4-13 and to 4-20 in the 14th edition manual. Those will now be available in the resource page before the end of the year. The new super tables that were not included in the manual for W shapes for 65 and 70 KSI members, HSS members, ASTM A1085 members, HSS A500 grade C, and pipe members will be on the resource page. And the new ZNet table for COPE W shapes are going to be on the resource page. This will all be available by the end of the year on AISC's website. What I did want to tell you is the Steel Construction Manual is available now. Also, as I told you, I compressed a lot of information into a 1-hour presentation. If you want to go to a full 4-hour seminar, go to www.aisc.org/seminars. You can see these are the future seminars that are scheduled for the rest of this year. September 28th in Pittsburgh, November 1st in Atlanta, and December 8th in New York. There will be more locations coming in 2018. To keep on top of those, to find one that is near you, just go to www.aisc.org/seminars, and I'm sure you'll find one near you. I also wanted to tell you about a special offer. For all of you listening today, the new 15th edition manual will be available at a regular price, but you will also receive a free copy of the 2nd edition AISC Seismic Design Manual and free shipping if you're in the United States. To get this offer, just go to www.steelday.org/manual starting on Friday, September 15th through Monday, September 18th. And you'll be able to get this offer, not only get the new 15th edition manual, but you'll also get a free seismic manual with it, and if you're in the United States, free shipping as well. Well, I want to thank all of you for attending today, and I'd like to turn it back over to Christina for questions.
Okay, thank you very much, Larry. Before we get to question and answer, we would like to do a quick polling question just to make sure that you guys are paying attention. Here's the question. Which of the following is not new to the 15th edition manual and 2016 standards? W-shaped column tables for 65 and 70 KSI, complete change to the AESS provisions, increased hole size for all bolts, effective length is now L sub C, not KL, or is it larger HSS sizes added to the manual? You can go ahead and select your answer on the screen. Just pick one of those radio buttons and hit submit. Again, the question is, which of the following is not new to the 15th edition manual and 2016 standards? Okay, Larry, let's check out our answers. It looks like about 65% of our participants are saying increased hole size for all bolts is not new to the 15th edition manual. What's the answer?
That is the correct answer. What is in the 15th edition manual is increased hole sizes for 1-inch and larger diameter bolts. For the smaller than 1-inch diameter bolts, the hole size remains a 16th inch oversize. For 1-inch and larger diameter bolts, it's an 1/8 inch oversize.
Okay. And let's move on to some of your questions. First question, I'm going to take us to slide 46. If the EOR delegates connection design to the detailer, option 2, how is the EOR responsible for showing stiffeners on design drawings? Shouldn't this be done in the detailer's job?
Well, I think what you have to remember, a detailer selects or completes connection design from tables that are in the AISC manual. So when you look at tables that are in the AISC manual, it's pretty much selecting them from the loads that are given on the drawings. I think when you're reading about option 2 in the Code of Standard Practice, it's very essential that you read the commentary that accompanies it. So it does not involve any engineering. Developing of stiffening required for local loading is engineering. Sizing connections from selecting from a table with loads on a drawing can be done by a detailer.
Okay, thank you, Larry. Our next question, you referred to some new 200 KSI bolts. Can these bolts be hot dip galvanized?
No. The short answer is no. The 200 KSI bolts cannot be hot dip galvanized. One thing I did not mention, which I think is essential to mention, I said look up information on the F3043 and F3111 bolts, is they cannot be used in any area where they would be subject to corrosion. That means you can paint them, but keep in mind that paint does go away after a period of time and needs to be repainted, and you may have this in a corrosive environment. One example I give is I always thought when I first heard about these bolts it'd be great in bridge construction, but bridges are subject to a lot of corrosive environments and there's a lot of moisture in bridge areas, so they wouldn't be really suitable for that application. But they would be suitable for maybe some large truss connections in enclosed buildings.
Okay, thank you. Our next question, I'll take us to slide 71. Can you clarify what it means for something to be the preferred material? Does that mean that A36 plate is now more expensive and less available than the A572 grade 50 plate, and that the A500 grade B HSS tube is now more expensive and less available than the A500 grade C HSS tube? If not, could you please clarify?
Well, it's not more expensive, and let me explain to you why. This table was developed from a survey of fabricators of what material they were getting from their suppliers. And what was discovered is that, for example, when you're talking about HSS members, when people were ordering A500 grade B, the suppliers were supplying A500 grade C because it was dual certified as grade B or grade C. And that has been that way for probably about 10 years. So it doesn't mean that grade B is more expensive. It just means that you were getting grade C or the stronger material without taking advantage of the benefit of the higher yield stress for the material. The same for plate as well. When you're ordering plate, especially when you'd be less than 4 inches thick, more generally, you are going to be getting 50 KSI material, even if you're specifying or designing for 36 KSI material. So all it means, take advantage of what is being more commonly supplied in the industry and take advantage of the higher strength where you can. So there is no increase in cost. For a lesser material or greater material, there is no increase in cost either way.
Okay, great. And somewhat related, we have some new materials and then some new shapes. Can we expect the new rolled shapes coming out of most of the mills to follow these new values?
Well, that's part of the problem. They're listed. They are produced by some mills, not all of the mills at this point in time. And that's why I emphasize you should always check AISC's website to see what mills produce them, because we have that listed on our website. And also, don't forget to call your local fabricator. Just because it's shown as available or is being produced on AISC's website, that may be a shape that's only rolled once every 6 months. That might not meet your construction schedule for the project. So, will it be available? Yes, it will be available, but it may not be available in small quantities, and it may not be available as quickly as you need it for your project. Check with your local fabricator.
Okay, that's a very good point. Thank you, Larry. And unfortunately, that's all the time that we have for questions today. We have quite a few questions that we did not get to. We apologize, but we're out of time. So we'll work with you to get a response. Larry will respond, and we will send an email to you with an answer.